Join us on a voyage through the wormhole, your gateway to groundbreaking thinking on AI, space exploration, a healthy planet, and a more intelligent future. I'm your host, Jonathan Knowles.
The Wormhole is produced by Trillium Technologies, leading the application of artificial intelligence for planetary stewardship, space exploration, and human health. Help us explore what's over the event horizon by following us on LinkedIn and Twitter at trillium.tech. Together, let's build an intelligent future.
We would like to introduce our first guest in the series. Our guest today is my dear friend and colleague, Dr. Madhulika Guhathakurta. She goes by Lika. She's a senior advisor for new initiatives in NASA Heliophysics division. That is part of the Science Mission Directorate at NASA. For the past 2 decades, she has enabled the development of heliophysics as an integrated science discipline. And as the lead for NASA's Living with a Star program for 16 years, she made possible flagship missions such as the Solar Dynamics Observatory, also known as SDO, Van Allen probes, stereo, and many others that have truly revolutionized our understanding of how the sun shapes space weather in the solar system. She's been awarded numerous national and international awards, and she continues to, and has in the past and continues to champion the growth of FDL. Welcome to the Wormhole. So please have you join us here today. And I'd love to start by asking you a real important question here. Why doesn't the sun have to go to college?
Because it's already it's got millions of degrees if you go to the Corona. Like, excuse
there
me.
You go. You knew the answer. Most excellent.
Thank you.
Oh, of course. It's so good to have you here, and it's always a pleasure to spend time with you. We're going to cover a few different things in our time today. I'd love to start by asking you, because you've been doing this quite a while, and you are a fantastic example of a scientist, in my opinion. What was your science journey? How did you end up where you are today in science and just in life? What was your journey?
Interesting question. This is like asking a star what's its life cycle. I mean, it's circuitous, kind of like orbits of planets. You know, you have a bump in the trajectory, you change course, you change direction. That happened a lot in my trajectory, actually. Haven't been completely deorbited yet. But jokes aside, you know, I could give you a slightly longish answer to how I was inspired to become a scientist that I am, you know, an astrophysicist and whatever else we might ascribe to myself. Don't know. And how I actually fell into the study of sun. So basically, you know, from a very young age, my fascination with astronomy, astrophysics began to blossom, fueled by the beautiful night skies of Kolkata. Without giving my age away, let me tell you, the skies were not this polluted back then, where I spent my early childhood, and I vividly recall the awe-inspiring moments, you know, spent gazing at the stars from the terrace. A cherished memory, I suppose, that ignited my curiosity about the cosmos at that point, basically. And I remember that I would, even at that young age, drive my father up the wall with my question. These are difficult questions for anybody. You know, where do we come from? Where do we go when we die? I had lost my grandmother, who was very close to me. So these were very powerful questions in my mind. My father, who was a banker by profession, but he was really more a philosopher, a poet, a mathematician, he would respond with reason and logic. And I still remember he made me draw a circle. And then he asked me, well, can you tell me now where the beginning or the end is? He was teaching a 6-year-old that some questions do not have answers without saying so explicitly, without shutting me out. And that
Mhm.
circular form, perhaps in the shape of the sun, became the gravitational point of my career. So these are all sort of general answers. And I want to take time to explain this because I have so many young people who send me emails, ask me questions, and I want to take the time to say how I came to be where I am. So my father played a very pivotal role in nurturing me, right? Taking all the children to planetariums, movies, indulging in our endless stream of questions about the cosmos. And back then, I would be just excited by looking at comets and Saturn's rings. And as I reflect on those precious moments from my childhood, I realize how they shape my journey into science. Each encounter with the night sky was really fueling my determination to unravel. Like, what is going on out there? And I knew nothing. I didn't know the word astrophysics at that point. And then so, it's not up until my undergraduate years in University of Delhi where I began to study science and physics as a discipline, where I also armed myself with math and chemistry and all of that. And so many people actually go to planetariums, love dinosaurs, look at the night sky. They all have that potential. That's what I'm saying. And we have to nurture that. So we need family, we need culture, we need society, we need universities without putting us down so that we can pursue that trajectory. And it's in my master's class, where I sort of took on the pursuit of astrophysics and cosmology. And that's where my journey began. And I left India, came to US to do my PhD.
And you ended up at the center of the heliophysics science community in Boulder, Colorado, which remains to this day the center of the heliophysics science community and space weather community in so many ways.
It's so true. And back
Yeah.
then, I didn't even know Denver existed as a city and Colorado was a state. My knowledge of geography wasn't that great.
Mm-hmm. How lucky for us, the world, that you did end up there. Now, you don't, you sometimes call yourself a heliophysicist, but since I've known you, you refer to yourself in a different way. And if you could tell us a little bit about what you refer to yourself as today, and tell us a little bit about what heliophysics is, when it started to become used, and what is really the significance of heliophysics as a science? Why should we care about our sun if we can go out and just enjoy the sun on a nice sunny day? But let's start with, what do you refer to yourself as? Because I love it. I think it's just great.
Well, I mean, this event happened not that long ago, about 4 years ago. LinkedIn on International Women's Day really wanted me to write a piece, and I had promised them I'd do so. This is back in 2020, just at the crossroad of COVID. I had come back home and I realized I hadn't written anything. And I said, okay, it has to be kind of clever with the right amount of balance, because I just don't like to go off on saying we are not nurturing young women and kind of make young men feel sort of alone. So I started figuring out, how do I introduce myself? Where do I go with this, right? And I wrote a little synopsis on my own self and my journey. And the title was Heliophysics. It's a play on words.
Heliophysicist. I love it.
Heliophysics.
It's great.
Because
And it's
heliophysics
so,
itself is a made up word, I'll tell you that.
it
And so,
personifies you, by the way.
yeah,
It just does.
Heliophysics is she who lives in a heliocentric world. Need I say more?
We certainly do. Well, it is heliocentric, and I think when we talk about that, you mean you, as we mentioned in the intro, you were the lead on living with a star at
Yes.
Science, and we really do. And I'm not sure how many people have that insight where they look at our sun and go, "Oh, yes, that's a star." And not only do we live with it, we sort of live in it in many ways. So, talk a little bit about that in the science of heliophysics. And the sun's a big deal, but heliophysics is even more than just that fireball that we see up in the sky. Its area that it literally covers is significant. Tell us a little bit about that.
So yes, let me actually address some of the component part questions you had, right? So what is heliophysics? It's a made up word. Let's just start at the very beginning. When you're starting a new discipline, you don't have the luxury, and it's a connected discipline, as I will talk about, that to kind of go and latch on to something else. You have to create a word and define it. And so heliophysics is the integrated study of the sun, its planets, space environment around it, as a dynamic system. And it focuses on the sun's very turbulent magnetic activity and its effects on the upper atmosphere of Earth, as well as on the planets of the solar system and the surrounding heliosphere. So it encompasses many areas of inquiry, cosmic rays and particle acceleration, space weather and radiation, dust and magnetic field, reconnection, magnetic reconnection, solar activity, stellar cycles, aeronomy, space plasmas, magnetic fields and global change and the interactions of the solar system with our galaxy. It's everything under the sun, basically. But it is the magnetic field of the sun that dictates this interaction and is the most fascinating force which shapes the universe we live in, and that is the heliosphere. So, in a nutshell, heliophysics is a unique hybrid of astrophysics and meteorology. And now you know why it's so complex.
Now, we say the word heliosphere, and we're all familiar with the atmosphere, and some people are familiar with the thermosphere. And we know what that area is, what it encompasses. How big is the heliosphere? What does it encompass?
Oh my. I would rather someone does an internet search and tells me, but it's huge. Okay. So distance
So,
between sun and earth is 1 AU, and I'd
right.
say it's over 100 AU. And all boundaries are tenuous. Nothing is rigid. And discipline boundaries are not rigid, but that's what we do, right? We get hyper focused. So the boundary where solar system ends, which is our bubble, which is the heliosphere, versus where the interstellar medium begins, it's a fuzzy boundary. And the two Voyager spacecrafts, as we speak, are navigating that uncharted territory to give us that information. So it's
Quite
100
phenomenal.
plus AUs.
Yeah.
One
It's
astronomical unit, distance between
much
sun and earth.
much larger than we would think of in our normal day-to-day activity when we think about the sun's influence. It's significant. It's a star. It's a star. There's a lot going on. So let's talk for just a minute about, before we take a quick break here, let's talk a little bit about some of the missions that you have been a part of, and really some of the findings that just in your career for the last couple of decades that were just wonderful aha moments for you when we started to have a little better understanding of our star.
Oh, well, I'll start with my first mission. It's special to you like your first child. I can't tell this to my daughter. I have a son. SON also, who's my first child. It's not true about children, but missions, yes. And stereo was the first mission. And I was brought to NASA headquarters from Goddard, where I was actually a card carrying scientist doing my own research to do the stereo mission. Stereo mission, it's a set of two spacecraft that essentially left the sun earth line. That is our vantage point when we look at the sun. And they went around kind of like earth orbit, one leading, one lagging, giving us the first three-dimensional view of an heavenly object. Have you seen anything else in three dimension? You haven't. It gave us solar storms and delving into it, seeing the magnetic field sort of, twisted and torn, coming all the way to Earth. It gave us a 360 view as the spacecraft moved around the sun. So there was a moment in time, a period, when we could see the front of the sun and the far side of the sun at the same time, on the palm of our hand, basically, right? Because we created tools, iPhone tools, app, with which you could see what does the sun look like on the far side. So these are stereo just sort of revolutionized our view of the interplanetary medium. I started using the word interplanetary space weather. Space weather is not special just to our planet. With stereo spacecraft, we could actually see when storms are happening, coronal mass ejections, flares that are going to Venus or Mars or Mercury or Jupiter. We created models, right? And we could see the impact it's causing there, and we could measure them with other NASA satellites or other agencies' satellites. Stereo is absolutely phenomenal. Two tiny school bus sized spacecraft that has allowed us to view solar wind that we talk of. We can't touch it, we can't see it, right? But with stereo, we actually took images of solar wind. So it was no longer kind of something we don't see. We felt we are in it. I'll end there. There's just
What
too many.
what
Oh, it's just
experience?
insane.
Feel like we're in it. Yeah. I love it. Well, we're going to do this. We're going to take a very short break right now. We're going to come back in just a few seconds. And so those of you tuning in, if you stay with us, we're going to come back and spend some more time with Dr. Madhulika Guhathakurta, NASA scientist, currently serving as the senior advisor for new initiatives in NASA's Heliophysics division, which is part of the Science Mission Directorate at NASA headquarters. Lika, we'll be right back with you. We're continuing our conversation with Lika. It is NASA has designated 2024 as Heliophysics Big Year. One of the things that is always interesting to me, Lika, is or are the people over the years, and I love knowing that you have collaborated with some of the and been mentored by some of the people who have helped us move ahead significantly in our understanding of the sun. If you could take a minute just to talk about a couple of them that would encourage other people to go and look into their story. I'll start because I think one of the good ones would be Jack Eddy. And he's become more and more in just the last few years someone that I've been paying a lot of attention to. But you've known these people, you've worked with these people. So tell us a little bit about a couple of the people involved on your journey.
I will most definitely do so. But I want to say this, in the beginning, that to create a new discipline to lead the Living with a Star program. It's a unique program in NASA history and remains so. It is really doing science, curiosity driven science that is relevant to life and society. That is the goal. So, in general, truly too many to name, the field was created by a village of scientists and not few individuals. But you brought up Jack Eddy, and I'll bring few more.
Okay.
Jack Eddy was a pioneering scientist back in the 70s. He made the first connection between sun and climate. And for that, he was punished. No good deed gets unpunished, as the saying goes. I wish it didn't. And gradually, with time, people, and he did reading analysis to kind of get to this scientific aspect of that understanding. So he, to me, represented interdisciplinary science, and that's what we are. I told you how many different things kind of really compose the field of heliophysics. And so Jack Eddy actually, or rather, I worked with him. You know, he was a consultant to the Living with a Star program, really advising and shaping this interdisciplinary science. When he passed away, in his honor, I started a fellowship called Jack Eddy Fellowship, and that happens to be the most prestigious fellowship in the heliophysics division, a named fellowship. You know, we are always trying to kind of admire the astrophysics named fellowship. There is a kind of little bit of sibling rivalry, right? So who could we name our fellowship after? And it's interdisciplinary science. So we have over 40 Jack Eddy fellows today. Some have become, you know, they are mid-career, established career. They are someone or somebody in their field, not just in the US, all over the world. There are places in the world they started heliophysics department, basically, when the students came and studied heliophysics in our summer school. So, you know, he and the textbooks that we created. So, what's a discipline, right? I kind of gave you the components of a discipline to integrate this disparate science together into something coherent requires that we take students through really some textbooks, some guidance. That's when I started the heliophysics summer school with UCAR in Boulder, Colorado, and that's like back 2006-7 timeframe. And these textbooks were written basically very coherently. It is more reference books than textbook. There are 5 volumes now that talk about heliophysics as an integrated science. And I couldn't have done this. I wouldn't have undertaken this journey if I didn't have Professor George Sisko, who is no longer with us, from UCLA and then Boston, a renowned plasma physicist, and Dr. Carl Schreiber, also retired from Lockheed today, again, a solar stellar physicist. And together, they created the marvel of the heliophysics textbooks.
Wonderful. People, you know, it's all about the people. And by the way, I'm looking forward to when I'm telling, whenever I'm able to put you in the list of people that I talk about when talking about Eugene Parker or Jack A and so many other people who've just done so many interesting things. So let's talk a little bit about the current state of heliophysics research, because speaking of that name Parker, the Parker probe. Tell us a little bit about this very exciting thing that it's the fastest thing that humans have ever created. Tell us a little bit about the Parker probe and why it's important and what it's going to help us better understand about our sun.
It's kind of fascinating. So, you know, sometimes I feel I stayed on at headquarters this long just to see that mission actually fly, which it did in 2018, and then give us the data, right, to really kind of see, was it worth it, right? And I can tell you, in the beginning, I was having my doubt because the data we were getting, which is again close to 1 AU or Venus orbit, where we have seen data before, and I was beginning to doubt, my goodness, we've spent so much money, so much resources, so much energy. Did I do right? Because I pushed it. I pushed it very hard. And now that we are getting the data from the close encounter, the perihelions, every successive Venus gravity assist takes us closer. And in 2024, December 2024, we are actually going to achieve the closest distance, which is close to 10 solar radii from the center of our sun. And the observations we are seeing, because we have to write books about it, how can I give you an answer, right? It's absolutely breathtaking, amazing, some of which is verifying some of our old ideas, some of which are discarding our old ideas. Some of the things, the wave particle interaction, the tying in of the magnetic field to the surface of the sun, I mean, these are things we haven't seen, and therefore we haven't thought about how to address them. At the end of Solar Probe, in the next 5 years, we are going to rewrite textbooks of how a corona, whether solar or stellar, is heated, and how particles like solar wind gets the momentum to shape the heliosphere.
It's one of those things that was a mystery for so long about the sun that we're just now starting to understand, isn't it? The old, if you hold your hand close to the surface of the sun, it's, of course, very hot. And if you did that to a campfire and pulled your hand away, it would get cooler. But on the sun, if you pulled your hand away, it would get even more hot as you did that.
Basic law of thermodynamics, corona defies that. But then what? How does it get heated? How does it energize the particles? Lots of fascinating observation, lots of new kind of understanding have been reshaped by actually seeing the data, both in situ data, so you're locally actually measuring the environment of the sun. When we have looked at the sun in the past, and we still do, it's remote sensing observations, which are imagers, but you are doing line of sight integration, right? 93 million miles. There could be lots of stuff in between. And we have to import that data to get information. When we have flown in situ observatories like Ulysses, that would be at 1 AU to 4 AU. So you're not anywhere close to the sun. Everything has been simplified by then. And so we said, we need ground truth observations. And this spacecraft is actually like a probe, taking the temperature, measuring the magnetic field, determining the pressure in sun's environment.
And doing it while traveling, and doing it while traveling at 500,000 miles per hour currently.
Yes. So,
Crazy.
I want to add another thing, because we so rarely get a chance to talk about what heliophysics is. So Parker Solar Probe is the closest mission that we have sent in our solar system. And Voyagers are the most distant. Think about it.
Interesting. Yeah. I hadn't until just this moment ever framed it that way. That is really interesting to think that way about it. Wow. What we've seen in our life. My goodness.
And there was a time when I was the Voyager program scientist. I was the Voyager program scientist, the first Voyager program scientist in Heliophysics division when Voyager came to our division.
Wonderful. Wonderful. So you've been on, you've managed to be involved from one end of the sun's influence to the other end of the sun's influence during your career.
That's an interesting way of putting it. I had never thought of it that way.
Yeah, I love that. That's great. Well, we only have a few minutes left, and These days, of course, our collaborations that we're involved with, that you have been a part of, I would say not just a part of, but you are truly the founder of Heliophysics at FDL. It was because you got involved at FDL that Heliophysics even became a thing, and continues to be a thing to this day. We're currently working on the 2024 Heliophysics research, doing amazing things with data. You mentioned that about the Parker Solar Probe. We're doing and have done amazing, truly astonishing things with SDO data. So it's wonderful to look forward to all the things we have in the short-term future that we're going to be able to do. And we'll talk more about some of those in future wormholes, specifically adding yet another layer to that interdisciplinary approach to discovery. In this case, through FDL, it's through AI and ML that we're doing that. But when we think of the longer term of heliophysics and some of the things that you can imagine that we could do and perhaps should do as paths in research for heliophysics, what comes to mind? What would make you truly happy to know that we have pursued and perhaps discovered in the future of the science of heliophysics?
Yeah, worth pondering over. If the ultimate goal of heliophysics is to support space exploration, let's just champion that goal, right? It is everybody's goal in the space agencies. Then I would say that we have to understand the meteorology of space. And I choose these words with a purpose because everybody understands meteorology in Earth and what we have done in the last 40, 50 years. So if human species would like to go from being Earth dwellers to spacefarers, then we have to have the knowledge of meteorology of space. You can call it interplanetary space weather, you can call it heliophysics, call it by your favorite name. The game is the same, really. And that understanding will eventually lead to mitigation strategies. And in my current role, I want to add one more thing. How do
Please.
we do this? It's not just missions, right? So I am now exploring, as you have kind of already mentioned, Frontier Development Lab, AI. I'm exploring the intersection of heliophysics with cutting edge technologies such as artificial intelligence, machine learning, and leveraging these techniques, we are unlocking new insights into solar phenomenon, into solar sun-earth connected phenomenon, and advancing predictive modeling, which is very important for NOAA, for space weather forecasting. And so this convergence of traditional heliophysics with emerging technologies, with the amount of data we have over decades, space-based, ground-based, it is truly astonishing, and it just scratched the surface. And by the time we have scratched the surface, there are new tools coming on board. So keeping pace is a little bit dizzying, and
I
not a lot
always
of resources always.
I've always appreciated your outlook on that and thinking about possibilities and your engagement over the last 7 years on these rapidly accelerating technologies and new technologies that come along. I can absolutely imagine the 6-year-old Lika not being very much like the Lika that I know today with regards to curiosity and really knowing it's okay to say, I don't know, as long as we follow it up with let's find out. And you've always been a let's find out scientist, and it's been great. Well, it's been absolutely great to have you. One last and final thing. What inspiration would you like to share with up and coming scientists, or even people who've been doing it for some time? But we specifically in FDL, we work with postdocs and early career scientists often. And as you said, with the Jack Eddy fellowships, the same kind of thing. What would you one piece of advice that you'd like to share with people with regards to their science journey.
This is what I'd like to share. While all my life I have been into extreme science, even though my father wanted me to do fine arts with math, I was very good in math. That was a given. But I used to sing, I used to paint, I used to do these things, and he thought that would be a great combination. But I chose to do science. And I've come to realize that pursuing STEM should not happen at the expense of other disciplines. And as in all things, I think a fulfilled life is one of balance. So, one's sort of dogged pursuit should by no means shadow one's efforts in experiencing the vast richness of other human resources. And one may often hear people, dismiss these pursuits as unworthy, right? Or soft because they lack technical rigor of the STEM disciplines. And I'd say never make the mistake of giving up your passions for STEM, but integrate it. The greater your exposure to all human intellectual pursuit, the more robust both your life and your science will be. And I'd like to kind of end with a quote from my favorite poet, philosopher, perhaps guide, Tagore, who so eloquently put it, right? A mind all logic is like a knife all blade. It makes the hand bleed that uses it.
Wow, fabulous. Thank you. What a perfect way to wrap up things in our time with you today. Thank you so much, Lika. It's always a pleasure. I'm certainly looking forward to all the future collaborations that we'll be doing for hopefully a very, very long time to come. We appreciate you and your mindset. Thank you.
Thank you very much for having me.
Of course. And thank all of you for joining us here. We are grateful for you taking time out of your day to take a listen and join us in the wormhole. Please take a look at trillium.tech/wormhole for our upcoming interviews in this series, to more fabulous guests, and you can read about them on the website at that link. Thank you all for joining.